Okay, welcome fourth graders to another science lesson. Today we're going to be talking about motors and generators. I guess the first thing that we need to discuss is what is a motor and what is a generator. A motor is a device that changes electrical energy, like the battery in a car, into mechanical energy or motion. Okay? So it changes electrical energy into mechanical energy or motion. That's what a motor does. A generator does the opposite. It turns motion or mechanical energy into electrical energy. So you can see that right here. Turns motion into energy. We looked at the motor, okay? The battery, the electrical energy in a battery turns into mechanical energy, which is the wheels moving. Okay. A generator, as I already mentioned, turns motion into electrical energy. This is an example of a generator that does that. Now, these things are put in a huge field. They're like massive fans. Okay, they're about as tall as a building. And the fan is called a turbine. The wind comes through the turbine and it causes the turbine to move. Okay? Now here's a close-up picture of it. So once again, the wind turns it. The turning of this turbine is the mechanical energy. How does this mechanical energy get turned into electrical energy? Let's look at this close-up here. Okay, so this is a close-up view of this turbine here. Alright? Inside of the turbine, the fan, the turbine, is moving like this, which causes this loop to move. Okay, so it's going like this because the fan, this turbine or fan, is causing this loop to move. On the outside of the loop, this metal loop, is a permanent magnet. Okay? The north and the south poles, like we've talked about in our magnets section, are attracted to one another. And because they're attracted to one another, they are creating this magnetic field. And this magnetic field has electrons in it. It has electrical energy in the magnetic field, even though you can't see it. This turbine is turning the loop inside of the permanent magnet, and it is grabbing the electricity or the electrons out of the magnetic field. It's grab, 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 this metal loop. So as this metal loop is spinning inside of the permanent magnet, it's grabbing the electrons or the electrical energy, and the electrical energy then starts traveling down the wire. That electrical energy then can be used to power things. I mean, like devices that you have in your house, TVs, microwaves, blow dryers, your video game set, and that sort of thing. Alright? So once again, you can see the loop is spinning inside the magnet. This piece is called a shaft. Okay, the long thing that's holding the loop in place. You can see the green is the magnetic field. Hopefully, if you're looking at your notes close enough. All right. Now, there's two different kinds of electrical energy paths or movements. Okay. The one path is called a direct current. So the electrical energy basically is when the flow of a current is always in one direction. So you can see it's always going, it's not going backwards. It's always going in the same direction. It's not all of a sudden going backwards. No, it's a direct current. It always goes through, okay, in one direction. That's called a DC or direct current. The other one is called an alternating current or AC. And you can see an example of it here. Many of the devices that we use when we plug into an outlet is AC or alternating current. Basically, an alternating current the current flows down one way, but then it goes back on the same path. So it's going like this. Okay? It's alternating, going one direction, and then it alternates and goes the other direction. Here's what it looks like in your notes. It flows in a direction and then flows in the opposite direction. And once again, a lot of the outlets in your house are AC, or alternating currents. Here's some of the different ways that we create electrical energy. Okay? There is hydropower. What basically happens is flowing water can turn this little turbine here, which can create the energy. Something inside of here is probably the same thing that we got going inside here. Okay? The turbine is moving. There's probably a magnet inside of the loop, inside of a metal loop, inside of this wheel. And as the water turns the loop, once again, it's going to grab the electrons in between the magnets. You also have a nuclear power plant. A nuclear power plant actually has the ability to split an atom. Now, atoms are the electrons in an atom are moving like this, and they're going around the nucleus. When you split an atom, electrons are going to go flying all over the place. When those electrons go flying all over the place, that is energy. That is motion. Okay? So when that electron goes flying, it's creating movement, and that movement is going to be used to power other things. Okay? So a power plant can split the movement of the atom, and the subatomic particles like electrons, protons, are going to go flying, and that's going to create energy. It's like an explosion, and that explosion is energy. Right? I thought we had another one. There was only two. Hydropower, the nuclear power plant. You have the turbines here, the big wind power. Electrical energy is created from the wind here. I believe that is it for motors and generators. Once again, if you have any comments or questions, feel free to ask those in class. I hope you've enjoyed this science video lesson, and I look forward to seeing you guys in class tomorrow.